And good morning to everybody. We have the bell work up here, so if you guys and gals could complete this bell work, which is write the following compounds for the following two. We have combining the calcium and chlorine, and then combining barium and oxygen. So please do that for bell work, and then we'll get to yesterday's homework. Let's check the bell work for today. So we have both calcium and chlorine and barium and oxygen. Two common compounds that come together. But how do they look as a compound? So we have calcium and chlorine. We're going to have to use our periodic table. I don't think everybody's memorized calcium's charge and chlorine's charge. For the first step, we've got to write down the symbols and their charges. So looking at your periodic table, you should have Ca2 plus and Cl1 minus. Now the next step is we have the charges. Now we have to go through and switch the charges and use them as subscripts. For chlorine, since it's 1 minus or also just minus, it's denoted that there's a 1. It's assumed it's 1, so we're just going to say it is 1 there without having to write the 1. So once we switch them, now we have Ca1. If you want to put the 1 there, you don't have to. I'm just going to say I put the 1 there for now. And then you have Cl with a 2. So the final formula for combining calcium and chlorine is CaCl2. So if we're talking about calcium and chlorine coming together, we'll refer to it as CaCl2 or Ca1Cl2. So that's problem number 1 for bell work. Let's migrate down to number 2. Barium and oxygen. Once again, we've got to look at the periodic table. If you don't remember the symbols or the charges, that would be helpful. Bring it down. We have Ba2 plus, oxygen 2 minus. Next step is to switch them. So the 2 comes over here. 2 gets crossed over here. And when we rewrite this final formula, Ba2O2, make these little subscripts. Obviously, you guys can do that before I have to actually change it. So Ba2O2. Now, the last rule that we had yesterday, talking about and dealing with the combining of elements to make a formula, the last rule was if we had 2 common numbers or 2 numbers that are divisible by each other, we can reduce it. This is definitely reducible. The final answer can be either Ba2O2 or BaO. Either one works. We reduce the 2 and 2 because we divided them because they're like denominators or have a common factor. So either one of these work. For me, I always use the BaO. It just is easier to write. The lazier we can become, the more efficient we can become, the better it is. So those are our 2 bell works for today. Ending up, if we are having calcium and chlorine, we end up with formula Ca1Cl2. And if we combine barium and oxygen, we end up with Ba2O2, or simplified into BaO. The next set that I want to check is page 223, number 1. There are 5 of them, and let's go through all 5 of them. Please pause this if everybody isn't at that point, because I want to make sure everybody has a good understanding. And we're back. A on page 223, number 1, we've got potassium and iodine. We got to look up the symbols, look up the charges on the periodic table. We end up with potassium being K+, iodine being 1-. We take our arrows, cross them. Now, since they are okay, since they are like in their common denominator or common factors, they're 1 and 1. The final compound formula is Ki. Since it's 1 and 1, remember we don't worry about the charges once we switch them down to subscripts. It's absolute value. So it's Ki, or if you wanted to write K1, I1, that would work as well. So that's potassium and iodine when we combine it. The following number, or letter B, magnesium and chlorine. Look at the periodic table. We find out Mg has a positive 2 charge. Chlorine has a negative 1 charge. We take our arrows. The 2 gets crossed over in front of the chlorine. This -1, the 1 gets crossed over to the magnesium. So our equation becomes Mg 1. You don't have to put the 1 if you don't want. And then Cl2. And those numbers should be, and that's my fault, those numbers should be subscripts, not superscripts, as in they should be towards the bottom and not towards the top. So when we combine magnesium and chlorine together, we have Mg1Cl2, or magnesium chloride. Sorry about that. Letter C, sodium and sulfur. Periodic table, we have Na1 plus, S2 minus. We take our arrows, cross them over. Sorry about this, technical difficulties. Na, put this into Na2. This is the subscript, so this becomes a lowered number. S, and then Since Na is 1 plus, you can put a 1, you don't have to. I'm just going to put it here for the example, but usually from now on I would just write Na2S. So this is sodium sulfide, Na2S1. That is the chemical compound. So that's letter C. D is aluminum and sulfur. Aluminum has a 3 plus charge. Sulfur has a 2 minus charge. 3 gets crossed over. 2 gets crossed over. The charges drop. We rewrite the symbols. So it becomes Al2S3. The numbers get subscript. So it becomes Al2S3 with a 2 and 3 subscript. At this point, it's just plugging and chugging. Usually plugging and chugging, we have a formula, and we put it in there, we throw it in the calculator, and then finally we get an answer. This, we're plugging and chugging the charges, flipping the charges, taking off the positive and negatives to finally get a formula that is correct. And then we have aluminum and nitrogen for our last problem on page 223. Both of them have a 3 charge to them. Aluminum has a 3 plus, nitrogen has a 3 minus. So we have Al3N3. Now hopefully some of you out in our audience are saying, hey, can't we make that a lot easier because both of them are 3 and 3, both subscripts? Absolutely. If you want to take it down and make it simpler numbers, as in 3 divided by 3 and 3 divided by 3, both of them are 3, you can just write ALN. So this is aluminum nitride. Al3N3 is also aluminum nitride. Either one works. Later on in the year, I'll be very specific as in if you have to reduce it, if you get your points. For our first test or first quiz, if you put Al3N3, I'll take that for a full point. Or if you put ALN, I'll take that for a full point as well. So those are our first 5. You should have already had those answers because it says answers in Appendix E. We are going to skip 2 right now because that's taking our compounds and actually writing out the formulas. So we are merging on to the second half of our homework, which is once again just going through and forming the compounds. Now we're on to page 251. If for some reason we were going too fast or you didn't understand one, make sure it is on Google Classroom so you can go and figure out the answers and see it all again. So we're on page 251. We're just doing number 6 right now. 6A is sodium iodide or sodium and iodine. Looking at our periodic table, Na1 plus, S2 minus. Cross it over, cross it over. Take away the charges, so you end up with Na. Excuse me here. Should be Na. Oops. Sorry. And lowercase a 2s. So the chemical formula for sodium and iodine is Na2S. Calcium and sulfur, letter B. Periodic table helps us realize that calcium has a 2+ charge and sulfur has a 2- charge, meaning they both, calcium gives up 2 electrons and sulfur takes 2 electrons. We cross these over, do a little crisscross. We end up with Ca2S2. This could be a correct answer, or if you did the last rule, you could reduce it and end up with CaS. So we start with calcium and sulfur. We write calcium 2+, sulfur 2-. We switch over the numerical numbers on top to the bottom subscript, Ca2S2, and we can reduce that to CaS. Letter C, zinc and chlorine. Mashing those together to create zinc chloride. Now, chlorine is on the original periodic table as 1-, but zinc is not on the periodic table as a normal one because it is a transition metal. So that transition metals will not always going to be the same as a charge. So you could have referenced page 221 has the transition metals and their charges, or you could have looked up on the internet what was zinc's charge. So once you found zinc's charge was 2+, write it up there and cross. Chlorine's 1-, cross that. And when you throw zinc and chlorine together to form a compound, you end up with the chemical compound of ZnCl2. So that's C, zinc and chlorine to make zinc chloride. Letter D, barium and fluorine to make barium fluoride. We have Ba2+, F1-. Take our arrows, cross them over. Remember, we are only crossing over the numbers and getting rid of the plus and minus signs. They're absolute values. We end up with BaF2. We can't reduce any of these numbers. 1 and 2 don't have a common factor other than 1. So it just stays BaF2. So this is BaF2, also known as barium fluoride. And finally, finishing off number 6, we're throwing lithium and oxygen together. Their charges according to the periodic table. Lithium has a +1 charge. Oxygen has a -2. We take these, cross them over. So we become the 1 crosses over, the 2 crosses over. We eliminate the charges, and we end up with the chemical compound of Li2O, lithium and oxygen coming together, otherwise known as lithium oxide. So that's number 6. On page 251. Number 7 we're going to skip for right now because we didn't go over that very specifically yesterday. So I want us to give us another day to figure out how to actually name these. Just like today, I hope you guys understood how to make the chemical compounds. Writing the chemical compound names is just as easy. We've got a set of rules. We follow those rules. We always follow the same rules, and we never can go wrong. So following the rules in this class, going step by step, is always a benefit. So we will go on and do a sum of 16, and then we'll move on to our new stuff. Now we're on to the last set of problems, to page 251, number 16. A, C, and E. I'm just going to give you guys the answer for that. A is sodium fluoride, which is NaF, and I'm sorry, It should just be NaF. So sodium fluoride is NaF. We'll do calcium and oxygen. These should be superscript. Same as usual, once we have these superscripts, cross them, and we come down, the negative and positive go away, so we're just left with Ca2O2, and yes, we can reduce that. We can reduce it to CaO or Ca1O. Letter C, we're putting potassium and fluoride together. Our final answer should be Kf, K being potassium, F being fluoride, both having a charge of 1 and 1 plus. D, magnesium and fluoride. Magnesium having a 2 plus charge, fluorine have a 1 minus. Cross them over. Like I said, I hope I'm not going too fast. If I am, please slow this video down. We end up with MgF2. Magnesium fluoride is MgF2. E, aluminum bromide is AlBr3 after we've done the switches. So that's the final answer for E, AlBr3. The final one we're going to do today is lithium nitride. Lithium nitride has the initial charges of Li1 plus, N3 minus, cross them over, and we finally end up with the answer of Li3N. So we'll go back to the top again. So A was NaF, B was CaO or Ca2O2, C was Kf, D was MgF2, E was AlBr3, and F was Li3N. So that's how we take the compounds, binary elements, mash them together into a compound, and write the chemical formulas for it. Our next set is going to be our writing the names of these chemical compounds.